Thank you very much for the invitation. This is early morning, and I prepared a presentation which may be a little bit controversial, which may engage some discussions, and that's the reason why I wanted to be a little bit here, that some of the points that I make, some of you may not agree. On the previous, just to continue with the previous talk, I would like to add one of the important things is that I see that one of the reasons why indoor air quality is not very well represented in the regulation is a lack of agreement on what is an indoor air quality. And I think before we agree on this, we will not succeed. And I think it's necessary that we develop some metric, even a very crude one, and we start from there. We will be never able to fight or combat, fight with energy or go in hand with energy, because they have metric, so they can go and basically measure how much energy is used. We have trouble to measure what the air quality is, right? So we define it differently. So before we have this agreement, I think we have very difficult time to proceed in that. So I encourage everyone to start thinking about this, and I think there have been attempts in the past to create crude indoor air quality metric, and there were some, of course, controversies about that, and negative comments, criticism, but I think it's a time for us, otherwise we will be too late. And I see some developments in that area already, and maybe it will bring the fruits in the future. So talking about air quality, ventilation is often used as the air quality metric, right? So I would like to show you why it is why it can be considered as a metric and why it should not be considered as a metric. So, and also I would like to state from the beginning that everyone is an expert of ventilation, I think. Every one of us knows something about ventilation, right? When I talk with many people, many engineers, that everyone knows about ventilation. But apparently it is not that easy topic, and we should be more careful when using a ventilation as a keyword or key solution to all our problems. So let me start. So I always make a long introductions, and then I have no time to present all my slides, so I'm so sorry for that. So, but there is always the questions that are asked about ventilation, and these are listed, few of those. So people ask how much ventilation is needed indoors, and which modality, which outcome or which response is affected by ventilation, or which one should be used to set ventilation requirements. Should we use comfort? Should we use health? Should we use cognitive performance? Can we reduce ventilation in buildings? What is the absolute minimum rate? Can we get rid of ventilation completely? Or do we need some ventilation? So there is a lot of epidemiological data on ventilation and the human outcomes. And can we use this for setting ventilation? And then the question is, can ventilation be used as an IQ metric? And finally, they always discussed, issue of whether we should use natural ventilation or mechanical ventilation, which one is better. So my presentation will try to address some of those questions, maybe indirectly and not directly. But there are also common beliefs about ventilation. I think every one of us thinks that more ventilation always improves indoor air quality. That lack of ventilation or low ventilation always means poorer quality. And there is also a belief that it is simple to measure ventilation. Everyone can do it. And then that ventilation can be used to predict human responses. So it is a performance-based metric. And also it is about this mechanical ventilation, that they work. I will come back to those common beliefs in my last slide and try to see whether this is true or not true, and try to discuss that further. So my presentation will start with summarizing what we know about ventilation and how robust and how good this information is. Then I will go there, and then I will discuss slightly about some specific issues about ventilation that we need to consider when we talk about it. So, we know that ventilation affects human outcomes, and this information is very, very systematic. So we know that if we increase ventilation, we will improve air quality. And that's very well documented in the standard, a European standard, or the draft of the new European standard and the previous European standards. So whenever we increase ventilation, we improve the air quality. Perceived air quality are here defined as a percentage of dissatisfied with air quality. There is also an evidence that shows that the odor intensity will improve, reduce when the ventilation is increased. Here, the slide shows the carbon dioxide concentration representing the concentration of human bioeffluents in the space. And then the lower the concentration, the higher ventilation, and the lower odor intensity. So we know that ventilation improves comfort. This is not to be discussed. We know that it is the case. We also know that ventilation will improve some of the health outcomes. And the best example for that is the relationship that is presented here. It has been developed based on the studies which reported the intensity of and frequency of self-reported acute health symptoms. They are called sick building syndrome symptoms. I would rather call them building-related symptoms. And this is a summary of several studies in the form of the quantitative relationship, which clearly show that the risk this is a prevalence of those symptoms will be reduced when the ventilation is increased. And of course, towards the higher rates of ventilation, you will see that these boundaries of confidence are not very convincing, but nevertheless, there is a trend in the data. We know that. We also know that if we increase ventilation, we will be reducing the short-term sick leave. And some of the data is available from the simulations, and some of the data is available from hospitals and jails, but also there is a data from offices and schools that shows that increased ventilation will reduce the short-term sick leave or absenteeism. And those effects are small, but still consistently seen across different studies. Also, there is a study, although on the self-reported common cold prevalence, that shows that increased ventilation will reduce the risk for the prevalence of a common cold. But you will see that there is a certain saturation of the level where the high ventilation rate will no longer be giving any effect, and also the prevalence here is also low. That would be one of the explanations. So we know that it improves comfort, improves our well-being, or perceived air quality, improves self-reported health symptoms, acute health symptoms. And we also know that increased ventilation will improve the cognitive performance. And that applies both for the work in the offices, but and also the performance of children in schools. So learning performance. And using the existing evidence, the relationships were developed that show that the level of the improvement, again the quantitative relationships, there are that support that. And this is for the office work, and this is for the school work by children in elementary schools. Finally, very recently, we have learned that ventilation has an impact on sleep. This is in the environment. A bedroom is where it is completely unknown. We don't know really how indoor environment affects sleep. We expect that it affects sleep, but very little information is available. So there are a few studies that do show that by improving air quality in bedrooms, by basically increasing ventilation in bedrooms, sleep quality and the next day performance will improve. And This is extremely important because sleep is an extremely important attribute of our life, and we get to know much more now today how sleep is important for our next day performance and for many of the diseases that are prevalent now, including, among other, Alzheimer's diseases. So if ventilation is important in our bedroom and air quality is important, we need to think about how to provide ventilation in bedrooms. But very little information is known. The two studies that are reported here, the one was basically providing increased ventilation, the other one was basically providing a personal solution to the breathing zone, and then in this way improving the air quality of the sleeping person. So we have about 3 scores of studies on ventilation and human outcomes. And they have been summarized in several reviews, and some of those reviews are listed here on this slide. And so I would say we have decent information, but not sufficient enough, to be honest. What we know from these studies is that, as I said, more ventilation improves human outcomes. And but it is difficult to define which ventilation rate should be used universally. So in some studies, ventilation is 5 liters per second, in some studies 10, in some 20, in some 30 liters per second per person. So it's difficult to say, to select one number and say, okay, this number should be used universally. And this is a limitation of all the information that exists. There are some minimum ventilation rates. We can say what is the absolute base ventilation rate, I would rather say, not minimum ventilation rate, at which health outcomes can be avoided. So there is some studies which basically show what was at the low ventilation at which no effects have been seen. And then multiple outcomes are affected by ventilation, as I said earlier. And we cannot establish clear causality. So we cannot say whether this is because of that or because of some other reasons. We know that if we go above 10, above some studies about 17, 15, about 25 liters per second per person, and this is the highest, we can reduce acute health symptoms. So on a safe side, one could say we could be, if we ventilate with more than 25, 30 liters per second per person, we could be nearly certain that we would avoid problems for health, or symptoms and comfort problems. But this is quite a lot. 25 liters per second per person. It is, first of all, it's not only challenging for energy issues, but also challenging technically how to provide that much to each other person in a space. Consider this space where we have probably 50, 60 people. That would be huge amounts of and avoiding all the other problems related to the delivery of so much would be a really issue. But also, there is as I said, studies show that if we go to 6, 7 liters from the epidemiological data, then there are studies that show that at these levels there are no effects, negative effects, even at this low level. However, for schoolwork and office work, for schools and schoolwork and office work, those minimum effect rate is a much higher ventilation rate, and it's probably 15, 20 liters per second. So one of the important issues also that is shown in these reviews is that the maintenance of ventilation system is an important confounding factor. So there is large evidence, but there is also limitations of those data. So we have, those studies are difficult to compare. Basically, they use different methodologies, they use different approaches to measure ventilation, and they improperly characterize buildings and exposures. So they characterize ventilation, but they do not say what type of pollutants there are in the spaces. So basically, we don't know whether in the other buildings there were different pollutants or the same pollutants and so on. There is also limited information on the sources of pollution in the buildings which were investigated. So, and also no information on maintenance. The assumption of a clean, unpolluted outdoor air is really an issue, because many of those studies assume that outdoor air is basically clean, which is not the case, and we learn more and more about this. And there is a weak characterization of effects. So we usually we use self-estimate or self-rated responses of occupants. And that to me is really an issue, because we need to have some strong evidence, especially if we, for the regulation purposes, we need to have some objective measurements to support those findings. And then we have very little information on chronic outcomes. So we don't know. I mean, these are acute effects that we see normally. And what about the chronic effects? Is there any correlation between the chronic diseases and the ventilation? That information is not available. One of the most critical problems in all the studies on ventilation are the ventilation measurements. So they are assumed, I mean, they are improperly or inadequately reported. Basically, there is a high level of uncertainty. It's a spot measurement. They are no long-term measurements. We don't know the variability of ventilation over the time, and so on and so on. So we really cannot say whether the measurement is representing the actual ventilation in the spaces. So evidence is there. It has certain limitations. But I think the most important issue that we need to acknowledge about ventilation is that ventilation is not the cause. In all those studies that looked at the relationship between ventilation and human outcomes, it is assumed that the ventilation is a cause. But ventilation is only a mediating factor. It is not the cause. So the cause is because of the exposure, human uptake, and then health effects, comfort effects on performance. Ventilation is modifying the exposure, as same as the sources are modifying exposure, sources of pollution. And ventilation can reduce the exposure when you provide air that is not containing the pollutants that you want to remove or dilute. Or it can actually also, ventilation can also bring in pollutants from outside, or bring in pollutants if the system is polluted or the outdoor air is polluted. So, important issue here is to acknowledge that ventilation is only mediating. So it's very difficult to use it as the IAQ metric, because depending on the outdoor air pollution, depending on the type of sources indoors, the exposure, the resulting exposure will be different, and the requirements for ventilation will be different. This is clearly shown in this graph, which shows how ventilation changed through the history. So you can see the first one reported was about 2 liters per second per person for the miners in the mines, of which 1.5 liters per second per person was to support the candle to burn, basically. The rest was for the miners. Then, through the Billings time, when he was looking at the diseases and tuberculosis, where there was 30 liters per second per person. And then, today's ASHRAE requirements and European requirements, they are about 10 liters per second. But the changes are because of a political approach and compromises, but also because of the different types of outcomes that are used to set the ventilation. So, what should be done in the future? How we can advance ventilation? I think in order to advance ventilation, we need to acknowledge that this is a mediating factor, and that there are sources of control, the sources, pollution sources indoors and outdoors, that needs to be firstly controlled, and then we should apply appropriate ventilation measures. So engineers that are responsible for ventilation should not be responsible for the types of sources that are brought indoors. They should not be this is not their response. They are not responsible for the fact that there are cars driving and that there is a pollution outdoors, and that someone is bringing strong sources of pollution indoors. So source control should be delegated to someone else and should be first properly regulated, and then the ventilation is the second instance in which we can control the indoor air quality in spaces. As I said. So what about those common beliefs? So if we look, and to summarize this, and if we look at and discuss what we know about ventilation and whether those common beliefs are true or not. So in all the cases is yes and no answer. So this is true that more ventilation always improves, in some cases improves ventilation, but more ventilation can also bring pollution from outside, so then it will not improve. Lack of ventilation or low ventilation rates means poor air quality. I mean, if the sources are very low inside and outside, then even if you have low ventilation rates, you can still provide good air quality. So it is not always the truth that is that lack of ventilation will mean poor air quality. Measurements of ventilation. It is simple if you know what to do and how to do, but generally it is not a simple task. You need to consider it very carefully and consider several aspects in order to do that properly. Ventilation can be used to predict human responses. Yes, it can be. It is a performance-based metric, but you need to very well define the exposures. And then finally, outdoor air and the systems are clean and free of pollution. And that is certainly no, because it's only certain areas in the world, in Europe, where you can assume that. And there has to be a very good agreement on that outdoor air needs to be treated and systems need to be clean before even considering that the ventilation provides the benefits indoors. Thank you. Thank you for